In the last video, I started with a baseball team, but made it a more reusable and dynamic generic class called Team that supported not only a team of baseball players, but a team of any kind of player. Now it's your turn to create your own generic class. In the interface challenge, I created a mappable interface and introduced you to different map geometry types: point, line, and polygon. The challenge then created a map marker or icon and a map label, but didn't do anything with locations. In this challenge, you'll use another mapping example, but use location data in the output. As you're probably aware, you can use Google Maps to determine the location of any point on a map. Here I'm going to pull up Google Maps for a point in the Grand Canyon National Park in the US called Mather Point. You can see my point is by default a red marker, and if I right-click that, you can see numbers listed at the top. Two numbers, 36.06 and minus 112.107. These numbers represent the X and Y points for this map, or the longitude and latitude. Latitude is listed first. I will use this set of double values to identify our location of a point. If I click on those numbers, they get copied to my clipboard. If you want to use your own locations for this challenge, you can retrieve them this way. Again, I won't actually be mapping our points on a map, but generating code that would allow a map program to do it. In this challenge, you'll start with a mappable interface that has one abstract method called render. You'll create two classes point and line that implement this interface. You'll also create two specific classes that extend each of these for a mappable item of interest. In my solution, I'll be mapping US national parks and a couple of major rivers in the US. The parks will be points and the rivers will be lines. The data I'll be using is shown here. I'll be creating a park class that extends point and a river class that extends line to support this data. You should have constructors or methods to support adding a couple of attributes and some location data to your two specific classes. You can pass the location data of a point type as a string or a set of double values representing latitude and longitude. You can pass the multiple locations of a line as a set of strings or a two-dimensional array of doubles that represents the multiple points on your line. In addition to these classes, you'll create a generic class called layer. Layers in maps represent a set of data which can be layered on top of one another to present many different sets of data on a single map. Your layer class should have one type parameter and should only allow mappable elements as that type. This generic class should have a single private field, a list of elements to be mapped. This class should have a method or constructor, or both, to add elements. You should create a method called renderLayer that loops through all elements and executes the method render on each element. Your main method should create some instances of your specific classes that include some location data. These should get added to a typed layer, and the renderLayer method called on that. Sample output is shown here. Okay, so pause this video and see if you can build something along these lines. If you get stuck, come back and we'll walk through this together. I'll start with a class diagram, if you want to take a sneak peek at that first to give you a bit of a head start. Welcome back. This diagram shows how I plan to build this. You can see my mappable interface has the method render on it, and by default that's both public and abstract. I've also added a static method that will take a string and split it into a double array, which will have the latitude and longitude values in them. I've made two classes, point and line, abstract, because I don't really want anyone to instantiate these classes. Point has a location field, which is a double array, and will just have two doubles, the latitude and longitude. I also have a method that will print that array to a string called location, and then the render method is implemented, and the same with abstract line, except a line will have multiple latitude-longitude pairs, and these will be represented as a two-dimensional array. You could create a class called coordinate or pair, or something that had these two fields, and in the future that might be a good idea to make the code more readable, but what I am doing is good enough in this case. Then I'm going to have a park class extend point with just a name field. River will extend line, and that has just a name as well, for simplicity. Lastly, there's the layer class. This is the generic class, and it has a list of layer elements and methods to add one or more of these. It also has the method renderLayer. Okay, so let's build this. I've created a new project called Generic Class Challenge. I'm going to start with my mappable interface. And I want to add one abstract method, void render. I also said I wanted a static method on this interface. Remember that JDK8 gave us static methods on interfaces, both public and private. If you don't specify an access modifier, it's public by default, static double array string, to lat line with a string parameter called location. I'll split the string by a comma to get an array of string. The first array element is latitude, and I'll use the double wrapper class and the value of method to retrieve a double value. The second array element is longitude, so again, double dot value of to get a double back. And I'll return an array of doubles, just two here, the latitude and the longitude. This method takes a string, like one you'd copy from Google Maps, and it splits it by the comma in the string, returning an array of string. It gets a latitude as the first element, making that a double, using the value of method on the double wrapper, and it's using unboxing automatically in the variable assignment. And the same with longitude, it's the second element in the split string. And then I just want to return those 2 points as a double array, which is what that last statement is doing. Now I want to create two abstract classes in this mappable.java source file. Abstract class point implements mappable. Private double array location equals new double initialized with two elements. Here I'm creating an abstract class. The field I created, location, will hold two doubles, the latitude and longitude. But did you notice something interesting here? Even though I'm implementing mappable, I'm not getting any errors on this class. I didn't implement mappable's render method, so why didn't I get an error? I mentioned this on a slide, but I want to point it out here. Because this class is abstract, I don't actually have to implement the mappable's abstract method. Any class that extends this abstract class will be required to implement render if I don't do it here. But actually, I want to implement the render method, so I'll use IntelliJ's code generation tool to include an override for the render method on mappable. Before I add code to this, I want to implement a private method called location that just prints the location as a point. Private string location. Return arrays.toString passing location, an array of doubles I defined above. I'm just returning the latitude and longitude contained in the array here, ready for printing. I'll use this in the render method. I'll print out the current instance and then make a call to the location method. By the way, I probably shouldn't have used the same name for the array and method here. But anyway, the render method just prints out render, then the string representation of the class that's calling this method, followed by the location string in parentheses. I also want to include a constructor, so I'll put that after the field location. I'll just type this one in. This takes advantage of the static method on mappable that transforms a string representation of latitude and longitude like we'd get from Google and returns a double array. And that's it for the point class. The line class is going to be very similar. I'll just add this after point. Abstract class line implements mappable. Private double array of arrays location. For a line, I'll have an array of arrays, so I'll have an array of the lat and lon doubles. This means I'm using a two-dimensional array to represent all the points that make up a line on a map. I'll add a constructor, which will take a bunch of strings as arguments, which are the lat and lon values each represented as a string. Public line, string var args locations. Here I will create a new double array with the length from the parameter locations, and I'll assign that to the field locations. Int index equals 0, and then I'll loop through the parameter locations, calling the string to lat lon method, and assigning that to the field locations. This method takes a variable argument of string, so we can have 0 to many strings, each representing the latitude and longitude of a point in the line. I instantiate the locations field based on the number of strings passed. Then I've got a local variable index, which is just the position in the array. I'm looping through the strings that get passed to the method. For each iteration, I set locations using that index to what we get back from the mappable method string to lat lon. I pass a string to that method, and it returns a double array, which is just two doubles, latitude and longitude. I then assign that to the next locations array element. It's time now to add the private method locations, which is like the location method on point, except here I'll use the deep to string method. Return arrays.deep to string passing the locations field. Finally, I want to add the render method. I'll select override, then add my statement to print out the information. Once again, I'll print out the current instance and then make a call to the locations method. Now that we have the interface and abstract classes, this feels like a good midway point to pause. In the next video, I'll work on the concrete classes Park and River and create the generic class that will let us create layers of these. I'll see you in the next video.